Assalamu alaikum students. Today we are going to perform experiment number 3. In experiment number 3, there are two parts. Part 1 talks about the voltage and current divider rules, and part 2 talks about the superposition principle. Let's first look into the part 1. So in part number 1, we have two different types of circuits. In this circuit on the left hand side of your screen, you can see that we have three resistors that are connected in series. And how do we identify that these resistors are connected in series? It's very simple. You just have to see if the current that is flowing through one resistor is also flowing through the other resistors. You can see that all of them are in the same branch, which means the current that will flow through R1 will also flow through R2, and the same current will be flowing through R3. And thus we can conclude that all three resistors, R1, R2, R3, are in series. On the other hand, in this circuit on the right hand side, you can see that this current IS will be divided between R1 and R2. Therefore, R1 and R2 are not in series. In this configuration, whenever you have resistors in this configuration, you call that they are connected in parallel. And what is common in resistors that are connected in parallel? All of us know that the voltage across the resistors that are connected in parallel is same. On the other hand, if the resistors are connected in series, the current is the same. Okay. Now, let us talk about the voltage in the circuit where we have resistors connected in series. Let us say that the total voltage of the source is Vs. So what will be the voltages of each resistor? For example, what will be the value of V1? What will be the value of V2 and V3? Will V1 be equal to Vs? Or will V1 be equal to V2 equal to V3? Okay, so what are these values? The answer is that this voltage Vs will be divided between all of these resistors. And Vs will be equal to V1 plus V2 plus V3. This is what we know from KVL, right? Now, how do I find V1? For that, we have the voltage divider rule. And what does the voltage divider rule say? The voltage divider rule says that if I have V1, if I want to find V1, then it will be equal to the same resistance, R1, multiplied by the total voltage here, the source voltage, and divided by the sum of all of the resistors. Okay, so how do we come up with this rule? This is very simple, and we have to use the Ohm's law in this regard. Okay, let me activate my annotation so that I can write on the screen. Okay, now I will write something on the screen in order to show you that how do we get this equation of V1. If you look here, this part, Vs divided by R1 plus R2 plus R3, what is that? R1 plus R2 plus R3 is the total resistance of this circuit, okay, which is the equivalent resistance of this circuit. And we are dividing Vs by this equivalent resistance. So according to Ohm's law, V over R is the current. So this quantity Vs divided by R1 plus R2 plus R3 is in fact the current that is flowing in this circuit. So if I multiply this current by R1, I will get V1, right? According to Ohm's law again, I multiplied by R1. So this relationship here, V1 is equal to R1 divided by R1 plus R2 plus R3 multiplied by Vs, is achieved using this concept, very simple concept of Ohm's law. And you might be thinking that why don't we simply use Ohm's law to find the current and then multiply it by the resistance? The answer is the convenience. Okay, so in using this equation, we don't have to perform that intermediate calculation of current, and we can directly find V1 in terms of the resistors and the source voltage. Okay, so this is for the convenience. You know R1, R2, R3, and Vs. You can use these quantities directly in this equation to find V1. Similarly, V2 can be found by multiplying the resistance R2 with the current. And as I said earlier, what is the current? Vs over R1 plus R2 plus R3. In short, these are the equations that are called the voltage divider rule equations. Okay, no matter how many resistors you have in the series, you can come up with a voltage divider rule accordingly. For example, if you have 5 resistors, then for example we have R1 plus R2, R1, R2, R3, R4, and R5. Then V1 will be equal to R1 multiplied by Vs divided by the sum of all the resistances, and so on. So this is for the circuits where resistors are connected in series. We can find the individual voltages using the voltage divider rule. Now, as I said, for the parallel circuits, it is the current that divides between the different resistors. Okay. Now, on your screen here, in equation number 2, we have written the current divider rules. Okay. The current divider rule says that the current in one branch, for example, the current I1 in this branch, which is the current that is flowing through R1, will be equal to the total current multiplied by the other resistance, the resistance in the other branch, which is R2, right? In our case, which is R2. So I1 is equal to IS multiplied by R2 divided by the sum of the two resistances. Okay, in this way, we write the value of I1. Similarly, the expression for I2, which is the current flowing through R2, will be it will be IS multiplied by R1 divided by R1 plus R2. Okay, now things get interesting when we have more than two resistors that are connected in parallel. Let us say that we have a situation where we have three resistors like this that are connected in parallel, and these resistors are, let us call them R1, R2, and R3. And let us say that the total current is IS. We will use the same thing, IS. And we are interested in finding this current I1 that flows through R1. So how can I find this thing? It's very straightforward. I1 will be equal to, let me write it here. I1 will be equal to the total current, which is IS, multiplied by the resistances other than R1, right? Remember here, when we wanted to write I1, we multiplied IS by the resistance other than R1. So what is the resistance other than R1 here? It is actually the total resistance here, which is what? Which is the parallel combination of R2 and R3. So that's why I will multiply IS by the parallel combination of R2 and R3. And then, as usual, I would divide it by the sum of the two resistances. Which resistance? The resistance of this branch, R1, and the resistance of the other branch, the equivalent resistance of the other branch, okay? So, which means it will be R1 plus R2 parallel R3. Now, if you know this concept, you can extend it to any number of resistors that are connected in parallel. Okay, guys, very good. So now we, in order to summarize, and before I move forward to the next page, in order to summarize, I would say that when two or more resistors are connected in this fashion and in a back-to-back fashion here, which ensures that the same current flows through all of them, we say that they are connected in series. On the other hand, when the two resistors are connected in this fashion where they share their terminals, so this terminal of R1 is shared by this terminal of R2. Similarly, this terminal of R2 is shared by this terminal of R2. They are connected, right? When we have this kind of situation, we say that the resistors are connected in parallel. Okay. Okay, guys, now let's see what we are supposed to do in this experiment. I will stop the annotation so that I can scroll my screen. Let's see, how can I stop it? Yes, okay, I have stopped it, but I still have the annotations on my screen. I will remove them. Let me remove it. Okay, guys, so now we are getting ready to have a look at the circuits that we are going to design today. Okay, on the screen, on the left hand side of your screen, we have circuit number 1, and on the right hand side of the screen, we have circuit number 2. So these are two circuits that look very similar, but there is just one small difference between them. Okay, what is the difference? The difference lies in this branch here. If you can see here, in the circuit on the left hand side, this branch is connected. On the other hand, in this circuit, we have an open circuit here. Okay, in this branch, we have an open circuit. That's the only difference. Otherwise, all of the resistances are the same. All of the labels are the same. For example, this resistance here, it is labeled R3. This is R2. Same thing applies for this circuit. Okay, all of the quantities are same. The same voltage source is used, Vs, in both of them. Now, what are we supposed to do? We are supposed to build this circuit, both of them, one by one. We will build these circuits using multisim And then we are supposed to find all of these quantities. What are the quantities? All of the quantities that are labeled here. Okay, for example, IS, I have to measure IS using multisim. I have to measure I2, I3, okay? Similarly, I have to measure I4, which is the current that is flowing through R4. And while I'm measuring all of these quantities, I have to make sure that I connect my ammeter and voltmeter properly by taking into consideration the direction of the currents and the direction of the voltages, the polarities of the voltages, okay? So we also have to find V2, V3, V4, V6, V5, okay? So we have to find all of these quantities. And this is shown in the next page. So in the next page, we have the table which shows all of the quantities that we have to measure. Okay, as always, since we are not doing hardware, so please forget about this last row. So you have to record all of these quantities, IS, I2, I3, and so on, from your multisim. Okay, now let us move to multisim in order to see how to design the circuit. I will not show you how to design the circuit. You already know how to access different resistors and then place them on the workspace. I have done that for you. The only thing that we will do today is to show you how to find different quantities. Okay, let us first compare these two circuits. This circuit that I have drawn on multisim and the circuit of our manual. Okay, okay, here it is. You see what happened? I will make it, okay. Okay guys, so for you, I have drawn this circuit, the one here in your manual on the left-hand side of your manual. I have drawn it here. You can see that we have a 10 volt source and it is given in your manual that Vs should be 10 volt. It is given here, you can see. Similarly, R2 is 100 ohms. Where is R2? This is R2 here. Okay, this one is R2. So it is 100 ohms. You can see here easily that it is 100 ohms and so on. Okay, this is R3, 150 ohms. R4 is 220 ohms. It's given here. R6 is 330, which is this one. R6 is 330. Now, I have deliberately not drawn the circuit in multisim in front of you because I want you to be confident. I want you to draw it yourself. And while you are drawing it, perhaps some of you will make some mistakes, and which is a good thing because this is how you will learn. Okay. So by the way, this is a very straightforward circuit. You should not have trouble drawing this. Okay, guys. So this is the circuit that we are interested in. I will connect, or I have already connected the multimeters in order to find two quantities. I will pause here for some time for you to think that what is the quantity that this multimeter will measure. I'm talking about this multimeter, XMM1. What is the quantity this multimeter is measuring? I hope you might have realized by now that since this multimeter is connected in series with R2, it means I'm interested in measuring the current that is flowing through this branch. In other words, the current that is flowing through R2, which is labeled as I2. And the direction in which it is connected, it shows that I am actually measuring the current that is flowing from left to right, because the positive terminal is connected on the left-hand side and the negative terminal is connected on the right-hand side. So this means I'm measuring the current that is flowing from left to right, which is indeed the current that I want to find. I am supposed to find from the manual. Okay. Okay, guys. So this is about the current I2. The same concept applies for I3. What is I3? I3 is the current that is flowing through this branch, R3. So you have to connect an ammeter in series with R3 in order to find I3, and so on. Okay. I would not show you how to connect the multimeter for each one of the currents. I'm just demonstrating it for I2. You should be able to connect it again in other branches in order to find other currents. Okay. Now for the voltage, we have connected a multimeter in parallel with R3, and the polarity of this multimeter, it shows that we have connected the positive terminal here at the bottom of R3, and the negative terminal is connected at the top terminal of R3, which means I'm interested in finding the voltage across R3 that will have a positive polarity downward and the negative polarity upward, which is nothing but V3 as shown in the manual. If you would have connected this multimeter in such a way that this positive terminal was connected upward and the negative terminal was connected at the bottom of R3, then you would have been measuring minus V3. You would not be measuring V3. Okay, remember that we have to measure V3. And for that, we must connect the positive terminal of the multimeter at the positive polarity of V3 and so on. Okay, guys, so you have to make sure that you connect your multimeters accordingly for all of these quantities. Okay, now let me show you this circuit. In this circuit, as I said, that the only difference is in this part, in this branch. This is not short circuited like previous circuit. What I mean by that, let me draw again. What I'm trying to say here is that these two nodes, this one and this one, they are connected together, okay? They are connected together. So this branch is actually connecting these two nodes. However, here, these two nodes are not connected. They are not connected, which means that there will be no current that will flow in this direction because it is open circuit, okay? On the other hand, there will be some current that will be flowing from this node to this node. There will be some I5. I5 will be a non-zero current. On the other hand, V5 is the voltage. It is the potential difference between these two nodes. And since these two nodes are nothing but the same thing, and there is nothing connected in between these two nodes, I would say that V5 will be 0. Okay, so you have to carefully look at it, carefully look at the circuit and learn how to find these currents and voltages using multimeter, okay? You cannot just say that since these two nodes are connected together, V5 will be 0. This is valid, definitely, and this is correct. But the purpose of having these kind of circuits in the lab is to learn what is the right way of using multisim in these kind of situations. Okay, guys, so it is very important that you actually make the circuits like this and try to find all of these quantities using your multimeter. Okay, please do not ignore it. Don't simply write I5 is equal to 0 in this case and V5 is equal to 0 in this case. Try to do that. Okay, you will learn something important. And the same thing applies for all other voltages and currents. Okay, guys, now let us move forward. Let me stop the annotation. Let us move forward and see what are we supposed to do. Let me erase it. Sorry for this. Okay, guys. So as I said, we have to fill all of these tables. So please do that properly. This is for the circuit, first circuit, and this is for the second circuit. Now, once you fill these circuits, fill these tables, you have to answer these questions, okay? There are many questions and they are very important questions, okay? They are there to strengthen our concepts, okay? When you will read these questions, you may be confused in the beginning, but when you will read them carefully and when you will refer to the figure, to the circuits, you will understand that what the question is for, okay? What are we trying to ask? Okay, I urge all of you to please read them carefully and then answer the questions. They are basically revolving around the concept of parallel and series combinations, parallel and series connections, okay? And based on the parallel and series connection, the concepts of VDR and CDR are also dependent on parallel and series connections, okay? So that's why these questions, question number 4 and 5, for example, they are also indirectly concerned with the parallel and series concepts, okay? So please go through all of these questions and answer them. So there you can see that there are a number of questions here. And you don't have to write lengthy answers, okay? Just write to the point answers. Whatever we are asking you, please write that, okay? With this, we end part number 1. And in the next video, we will start part number 2, inshallah. Thank you.